we are running out of water, so we need to find water efficient or drought tolerant corn hybrids plus management technologies to reduce the amount of water required to produce corn. We are developing new corn germplasm by using exotic materials, especially from tropical corn. We're also evaluating commercial hybrids, transgenic corn technologies. And we select corn for a lot of traits. We cannot select corn for drought tolerance or water efficient corn just based on single trait. We have to select a large number of traits. So it's very complicated. So the water use efficient corn or drought tolerant corn is not going to be like a herbicide tolerant corn or BT. So it has to be incremental increase. So once you stress the corn, you will see leaf rollings and reduce plant height, staggering traits, and that's what you usually see. But the most important for breeders is what's going to happen inside the husk, the ears. That takes a lot of labor. We got to hand harvest those ears and wait for seed setting, grain quality kind of things. But after all, end of the day, what you really care about is still yield, yield, yield. We're studying what is the best combination to choose hybrids and plant population and irrigation scheduling. So we have 10 hybrids grow under 100% ET, 75% ET, 65% ET, and 50% ET in 3 plant populations: medium, high, and low. And also we have looking at grain, both grain and silage yield. So just give you a very brief data. In 2008, under 100% ET, the average yield for high population is 266 bushels, medium is 255, and the low is 234. Under 75% ET, in the high population stand, yield 268, 2 bushels higher than the 100% ET. Medium is 263, a little bit higher than the 100% ET, and low population 255. So what does tell you that these data show that we may be overwatering corn in this location. You can see this is a very thin, ugly plant. This is a little bit better, and this is a little bit still poor. Now, what farmers grow is F1 hybrid seeds. So corn breeding involves 2 major steps. One is to develop parental embryo lines. So these are embryo lines, and then we cross these embryo lines and make a hybrid. So it takes 8 generations to develop an embryo line. So if you have 2 seasons per year, it will take 4 years to develop an embryo line. You can develop a nice looking embryo lines, but does not mean they will make good babies. So the second one is cross these embryo lines and then find good babies. That's F1 hybrid. That takes another 3 or 4 years. So that takes about 7 to 8 years to develop a good hybrid.
You certainly should see what we indicated out on the turn row, that the difference between the 75 and the 65 is that breakover point for many of these hybrids, and you should be able to determine that the ear length sitting on that stalk is a little bit shorter, and certainly the circumference of diameter is, so the kernel field's not as good. So the days are coming when you pick a target water level and a variety to match that production level is here. And the combinations that are available are going to ever become increasingly confused